Hello people, welcome back to your Anime 101 course. Through this last part we will try to enhance rationalization processes using loops. Why loops? Because we cannot actually anticipate the results of a process like that. Or we can do it actually, but we will have to write a line of code or after another, or a process after another in Grasshopper, which becomes very ineffective. So let's get started. I have this minimal surface, which is a mesh. Actually, you can use any sort of surface you want. And I want to create an abstract representation of this surface using boxes. So let's get started. First off, let's assign my mesh. Sample mesh. Yeah, there you go. Hide. Next, what I need to do is create my box template. A center box. It will be 0.04 of size. I will divide it by 2. There you go. So this is a 0.04 box on X, Y, and Z. After that, I need to get a bounding box of the whole mesh in order to calculate contours of the whole shape. I will deconstruct the box. So now I got the size of this box. I will divide it. I will get to the mine end. Construct domain. There you go. So this is the size actually. I have to divide it by the size of the boxes, just 0.04. We'll turn this off. And I have to round this number in order to get the number of contours I actually want for my shape. Next, I need to create a series using the ceiling result. The step will be the size of the boxes. I will use to create contours. Contours X. This shape, which is the mesh, and I will use the offsets. Yeah, there we go. I got my contours, which are actually polylines, because this is a mesh. What I need is a softer representation of these curves. So I will explode polylines and I will rebuild it using an interpolate curve using the vertices. I will flatten this output and reparameterize it. After that, what I need to do is to create boxes at the very beginning of each curve. So I will evaluate curve at parameter 0. So this will be the starting positions of the boxes which I actually have here. It's these ones. There we go. So these are the initial positions of the cubes. Now I have to set up my loop start and loop end. For the core data, I need additional inputs. I need up to D3 here as well. We'll make this connection. So let's get started. First off, on data, I need to point the very first parameter. In D1, I need the tangent. In D2, I need the whole curves. And D3, I need the boxes. There we go. We'll turn off the rest of it. We'll turn off the mesh as well. Okay, fine. So what I need to do is to calculate intersections, possibly on the X or the Y coordinate. In order to do so, I need to deconstruct the tangent, which is D1. I need to deconstruct the tangent and evaluate the X and Y components in order to define the translation. So I will start with x. I will write if x is smaller than 0, we will use a negative vector -1, else we will use a positive. We will repeat the same process for the y component of the tangent. There we go. After that, we need to multiply each of these translations by the size of the cubes. This by the size of the cube, which is this and this. There we go. Now we need to set up x and y vectors using these amplitude values, x and y vectors, and we need to move the original points, the starting points, parameter 0. So let's move the geometry, which is data, which is data by x and data by y. After that, I need to repeat this process but using the other translation vector, the result this time by y and the result this time by x. And I need to create lines from these results, from this to this, from this to this. Hold this. There you go. After that, using these lines, I will calculate intersections with the contours. In order to ensure that we have intersections, we need to extend each of these curves. At the start point, we will use the length of the curve divided by 2, and at the end we will use 0. There we go. Now I will repeat this process for another line. And next, I need to calculate intersections between curves. I need to graph both inputs. So I want to calculate intersection between D2, which is the curves, and the current curve, this and this. There you go. So I got the intersections at the x translation and the y translation, which won't always be the same number of intersections. You can tell actually on the very first list we have 0 intersections, so we need to pick which ones we will actually use and use this as a pattern to remove the contours which actually don't have any other possible intersections. So we need to calculate the list length, the first one, and write an evaluate function using the 3 inputs. We will call this x, we will call this z, we will call this u. The expression will be if the list length, if x is equal to 1, pick the very first set of points, which is z, else pick the ones at the bottom, which is u. So z is list length, z is the first set of points, and u is the second set of points. This list is yellow. Why? Because we have no indices, which we can actually use in order to select which ones we need and we don't need. So first off, we need to calculate the curve closest point from each point. This should be flattened to each respective curve, which is D2. There we go. After that, we need to evaluate the same curve at this parameter, which we don't know precisely which one is it. So that's why we are using loops. There we go. Next, we need to find out which indices are actually null indexes. null values. So we need to use the null item component from this list. And null flags is the ones which are actually null or not. So we'll use as a call pattern to remove the points or the indices we actually don't need. We need to invert the pattern, sorry. There we go. We also need this pattern to tangent. We don't need. And also we need to remove the curves which actually don't have any other potential intersections. Copy and paste. This goes to D2. There we go. So this is our final contours which actually have still intersections. These are the tangents we need. These are the points we need. After that, we just need to create boxes. You can just copy and paste the ones we created at the beginning. At this point, there we go. This is the second iteration of boxes. The tangent should go into D1 to the D1 input. Boxes go to data. No, boxes go to D3, sorry. Data, we will get the points in here. For D1, we will get the tangents, which are these ones. And at D2, we will get the remaining contours. I will turn off the rest of it. And if I iterate, it will actually work. I need one more iteration. 2 more. There we go. So this is an abstract representation of a minimal surface, which actually works pretty well. And we are anticipating the rationalization processes using ellipse. So that's it. This is the whole Animal course. I hope you all enjoyed it. If you have any doubts, please feel free to contact me anytime. I'll give you my email. There you go. If you have any doubts, please feel free to contact me anytime. Thank you all for tuning in and see you next time.